Hi, I'm Andrew Bradshaw, partner and co-founder of RTC. Welcome to Property Care Matters, the video podcast series brought to you by RTC, your go-to source for practical tips and valuable insights on everything related to property care. RTC, the Northwest's leading property care specialist. Hello and welcome to another episode of our Property Care Matters video podcast. I'm following on from our previous podcast where we talked about how to prevent condensation and mould in our homes. Today we're going to be talking about ventilation in domestic properties. I'm really pleased to be joined by a well-respected ventilation expert within our industry, Paul Harrington. Hello, Paul, and thank you very much for joining us.
Absolutely, my pleasure, Andrew. Thanks for the invite.
No, pleasure. I'm glad you're here. Hope the travel down here was okay and everything like that.
It was good, yeah.
And sunny Blackpool's not disappointed.
Blackpool anyway, yeah.
Can you, before we actually start the podcast, can you just tell us a little bit about yourself and your involvement with ventilation, etc.?
Okay, yeah. Well, I guess we met through the Property Care Association. Yeah. In recent times, I've been responsible for delivering the ventilation Masterclass. I've been involved in the ventilation industry for nearly 3 decades, and predominantly working within the existing homes market with social housing providers, dealing with problems associated with poor ventilation.
Mm-hmm. No, brilliant. So moving on, firstly about sort of the ventilation side of everything. Sort of, are there any sort of current regulations involved with ventilation in domestic properties?
There is. I mean, our main set of regulations is approved document F, but it actually crosses over with other parts of the building regulations as well. So people may not be that familiar with this, but extract fans, for example, can starve open fluid appliances for combustion air. So as a consequence, you'd want to have a bit of a background knowledge on approved document J. There's part B of the building regulations, which is connected with fire. Why would that be important? Well, sometimes we have to pass ducts through parts of buildings that are protected from a fire safety point of view. So there are a number of regulations that cross over. Approved document F is our main one, and we've recently had a revision of it, so 2021. And that puts us in a bit of a strange position within the property care world, because we have post-2021 regulations, pre-2021 regulations, and then we have lots of guidance provided by the Property Care Association, which I would argue is an enhancement on the pre-2021 regulations. And I suppose what we do as professionals is we use our knowledge of all of those regulations, we use our eyes, and we decide based on all of this knowledge how we might improve the ventilation in a dwelling.
Yeah, because I think a lot of people don't actually realise, with ventilation, a lot of people think you just put a fan in, but there's a lot more to it than that.
Well, again, you might argue that thank God people do, because otherwise we wouldn't have a job.
Yeah.
But yeah, you can go down to B&Q or Screwfix and you can purchase an extract fan off the shelf, and you can pay an electrician to fit it for you. But the regulations, require a lot more effort and a lot more detail. So it largely depends on the method of ventilation that you're applying. And I suppose if we go back to basics, there are 3 main ways of ventilating a home. We can suck air out and let air from outside bleed in. We can push air in and let air bleed out, or we could use some quite complicated systems which actually push air, deliver air and take air out and recover some energy. And all of those different methods of ventilation really need to be sized correctly.
Yeah. So with regards, obviously, sort of extract, because one of the most common forms of ventilation is extract ventilation, but obviously there's so many different kinds. You've got your constant run, your decentralised fans, etc. Can you just give us a little bit of an insight into the different kinds of mechanical extractor fans that you can actually buy?
Okay, yeah. Well, there are two main types. Fans that work intermittently, so they sit there and do nothing until someone switches them on. And they have to be supported by lots of background or trickle ventilators in a dwelling, which are, in terms of the building regs, are designed to be left open so that air naturally comes in and out of a building. And when some additional ventilation is required, the residents or occupiers would use the fans to provide some additional ventilation. There are fans that run continually. And they provide a continual ventilation rate from what we call the wet rooms, so a kitchen, a bathroom, a utility room, a toilet. And those fans are sized typically based on either the number of bedrooms in a property or the floor area. Sometimes the number of occupants would have an influence. And if you apply that method of ventilation, you have to put quite a bit of effort into ensuring they're sized correctly. There are some fans that I would argue are a bit of a in-between, so they don't quite meet the ventilation rates that would be required for an intermittent system, but they provide a bit of continual ventilation.
Are these the ones where they're sort of on constant, a bit like the constant run, but they're on a little bit and then they boost, but the flow, the trickle's not as powerful as on some and maybe on the new kind of.
I think you commonly hear them referred to as sniffer fans.
Right.
So they'll provide some continual ventilation, but at a set rate. And then if they sense a rise in humidity, they will increase the amount of ventilation they provide. And it's difficult to see where they fit in with the building regulations, if I'm being honest. And I think that becomes a challenge because the way our industry has progressed over the last few years, there's much more focus on regulatory compliance. There are all kinds of laws that quite rightly are there to protect residents, particularly in a social housing environment. They're more than entitled to question whether the ventilation system serving their property is regulatory compliant. And professionals like us often are called in to comment on that. And I suppose when we do that, we will benchmark what's there against the building regulations.
Because when we talk about sort of flow rates and things like that, we talk the minimum flow rates, aren't they? Because obviously, depending on how many rooms are in the property, how many occupants live in the property, obviously you might need to increase the minimum flow rate that would comply with building regs to something which is going to actually solve the problem. So it's not always just a case of you put it in, you get those flow rates. In a lot of instances, we need to do a lot of work before that to determine, does that flow rate need to be increased to give them a better chance of removing the moisture and preventing the mould from forming.
That's a really good point. Building regulations are not the standard. They're a minimum standard. And of course, we see things on a day-to-day basis that would cause us to think the minimum is not enough. So fish tanks would be a good example. You can see some quite large fish tanks and water does evaporate from them. And as a professional, you might decide, well, actually I'm going to treat that as another person and up the ventilation rate accordingly. Pets would be another good example. And sometimes the habits of the people living in the home. All of these things, increase moisture production. And if you're working out how to best ventilate that building, you want to take that into consideration.
Yeah, one of the things we do find in a lot of properties where they've actually had fans installed is they haven't used the correct grills, or they haven't used the correct ducting, and people don't realise just little things like that have a massive impact on the flow rates. Can you sort of expand a little bit on that? Like flexi ducting, solid ducting things?
Yeah, I mean, think of it that you want that ventilation system that you've invested in to perform as best as possible, and you want that pathway through the ductwork to be as smooth as possible. So that would include the ductwork itself. So a rigid sleeve or pipe, we call them ducts, but that would be, the standard thing to use. And then depending on the type of fan that you apply, you would give some consideration to the external grill. So with fans that are running continually, it would always be the case that you would use a fixed louver grill without an inset mesh. For intermittent fans, we commonly see fans with backdraft shutters or gravity shutters. And as a little tip to look, if you're replacing an intermittent fan with a continually running fan, to check the external grill to see if it's the right type. If you can create a smooth pathway through the for the air, then the fan will run quieter. It'll consume less energy. And it'll move more air. So thinking of it as a complete installation is really important.
We often get asked questions about noise as well. How will I hear if it's a constant road fan? Will I hear it? Will it put me off? Will it stop me from sleeping? Something like that. But we find the whisper quiet. But what's your sort of advice about sort of the noise and the noise levels that fans produce?
I hope I'm not saying anything controversial here, but if you look across, and I work for a fan manufacturer, and if you look across the different ranges the fan manufacturers offer, they generally consume roughly the same amount of energy, move roughly the same amount of air, produce roughly the same amount of noise. And the main reason for that is that we're making them to suit the same set of regulations. But my opinion is that there's a maximum level that you can put a fan on without noise being an issue. So I call this tenant acceptability. And my own view is that with a 100mm diameter DMEV type fan, probably 8 or 10 or 12 litres a second would be the maximum. Now we produce data to show that the fan could be set at 16 litres a second. But if you did that, then you would create noise, and it would encourage the residents to turn the fans off. So it's very much the case that you have to carefully select the fan according to the flow rate that you want to achieve. And in terms of concentrical fans, which are a bit of a go-to for us in the industry, we're initially looking at what the whole dwelling ventilation rate is. So as I've referred to earlier on, that's based on the floor area of a property, the number of bedrooms, the number of residents, any other things that you as a professional might want to take into consideration. So you would determine that and then have a look at what's out there in the industry to be able to achieve that flow rate quietly or at a tenant acceptable rate.
I mean, we've got a noise meter there when we actually install the fans to make sure that, and it's very rarely we get a situation where it's found that the noise is going to be a problem. But obviously it's mindful of the fact that if you've got a fan and you're asking it to do too much, there's obviously going to be a downside to that, and that's obviously going to be, you're probably going to get a little bit of noise.
And note that I think things will improve because one of the changes that we saw in the last revision of the building regulations is that whole dwelling ventilation rates went up. So what we're starting to see is new products coming to the market that can help you achieve those whole dwelling ventilation rates quietly. So the industry norm would used to be a 100mm diameter DMEV fan. They're starting to get bigger. And I think that it's always worth remembering that our regulations apply to existing homes and they apply to new build. But you'll know, Andrew, that when we go to existing homes, and I grew up on a local authority, estate, right? So I'm a social housing lad. But typically, you have one kitchen and one bathroom. So achieving that whole dwelling ventilation rate, you've got two opportunities to do it. In a new build, it's much more common to have at least 3 and sometimes 4 wet rooms. So you can spread that hold well and ventilation rate across a number of rooms. So fans are getting bigger, there's no doubt about that, but that's good news because they're able to move bigger chunks of air quieter.
Yeah. And obviously one thing we've got here is obviously you'll know all about these anemometers, and we're quite surprised on that when people actually install fans, because obviously part of building regulation requirements, etc., you know, they don't actually check flow rates or anything like that. So you know, these anemometers are vitally important, aren't they? You can't really install a fan without having the flow rates checked, because how would you know what the flow rates you're gonna get from the fans?
Yeah, I mean, under the old regulations, you would have been allowed to calculate it, but the anemometer is a great tool. Actually, I use it predominantly to check the flow rates of existing equipment, because if I'm going to try and persuade a client that, you know, to change the ventilation strategy in a building, I want to actually demonstrate to them what's happening in the first place. So I'll use that tool to check what the existing ventilation system is doing. I'll benchmark it against the relevant regulations, and then if I can justify and if it's the right thing to change the strategy, then I'll use that information to demonstrate that to the client.
And in conjunction with obviously, because when we go and do a survey, we talk about, obviously we don't just say mechanical ventilation, that's all you need. We talk about obviously what the occupants can do as well. So how important with certain fans is things like cross ventilation, purge ventilation, etc., trickle ventilation?
It's vitally important. There are two things that are common to no matter which method of ventilation you apply in a building. Cross ventilation is one of them, which is achieved through door underguts. The building regulations state that we need a clear 10 mil gap above finished floor level. The actual term is 7,600 square mil, right? So a 10 mil gap above on a typical door. And then in theory, if it was a new build project and the carpenter didn't know what the floor finish would be, they would undercut the door by 20 mil. Right. So that's common to each method of ventilation. And then we have purge ventilation, which is openable windows. And that's there to provide some additional ventilation, I suppose, during times of peak moisture production. And that is sized correctly on a new build project. The difficulty we have if we're working in the existing home market is that it would be disproportionate to ask a landlord to change the windows because the purge ventilation didn't meet the standards. But to give you a rough idea, it does depend on how wide the window vent opens, but it'll be between 1/10 and 1/20 of the floor area it serves. Often we see restrictors on window vents, particularly in taller buildings. And again, if the window vent doesn't open wide enough, it cannot be considered part of the purge ventilation for that building.
With obviously we talked about mechanical ventilation, extract ventilation, but obviously, you know, the positive input pressure systems, PIVs. What are your thoughts on those systems in domestic properties?
Where they're correctly applied, I think they're a good method of ventilation. I suppose, you know, I'm going to declare an interest. I've got one in my own home, and I've actually had the same system since 1999. So a good method of ventilation. Many people will recognise that it can be controversial. It seems to be the Marmite product of the ventilation industry, but key is ensuring that it's correctly applied and correctly installed. So I was lucky enough to be involved in a large study of PIV in the late 90s, conducted by the Building Research Establishment. And I suppose I know more than most about you know, how PIV systems work. So you mentioned it yourself there. You said pressure, and that's actually how we referred to PIV back in the day, as positive pressure systems. But interestingly, the BRE were asked to quantify that, and what they concluded was that there's actually more pressure caused by stack effect in a building than a PIV system. So they actually work through dilution. I think that the podcast that you did previous to this, anyone that hasn't seen it, I think they should do is a great sort of setup to talk about ventilation. But you clearly indicate very well that outside air, and colder air can hold less moisture than inside air. And what good ventilation systems do is they introduce that and they dilute the air inside. And that's effectively how our PIV system works. It dilutes, displaces and replaces.
So where does the air go?
A great question.
Because we sometimes say that, well, but what happens to it?
Well, there are thousands of gaps in a home.
Yeah.
So let's think about it the other way. When we switch an extract fan on and it takes air out, we don't think about where that makeup air would come from, but it comes through lots of different places around the building, and it would be the same the other way around for a PIV. It will find its way out through sort of natural infiltration.
What's your I mean, one of the things we find, especially when we're going into a property where there's an existing sort of a PIV installed, we often find it's just in the wrong position. So it's like whoever's gone up there to install it has just wanted to put it in the easiest spot, which is right next to the trap, but that might not be the best place for it. So positioning is really vitally important, isn't it, when you're actually installing these PIVs?
Yeah, a good central position for the diffuser. Remember that when it comes in through the diffuser, it should carry across the ceiling. There's a term for that, it's the Coanda effect. And if the diffuser is placed too close to a wall, then you can get some draft that'll come down from the wall, and that can often cause complaints. So our weatherman would call it wind chill. But if you walk past an area where there's a draft, it'll feel colder than it is. So the technical term for this is evaporative cooling, but you want to avoid that and get the diffuser in a nice central position. Be aware that it's got to be away from the smoke detector, and all of us manufacturers will provide that advice in our installation details. But there are other things as well, ensuring that the loft hatch is well sealed, ensuring the loft itself is well ventilated enough, looking at any pipes that penetrate the ceiling to make sure they're sealed, because it will always take the path of least resistance. So with a PIV system, you want to make sure that least resistance is air that comes in through the roof itself.
And obviously, you talked before about sometimes when you're walking underneath the diffusers, you get a little bit of cold air. You can obviously get PIVs with a heater element. It's not warm air that's being produced. It's slightly warmer air, isn't it? What's your views on the heaters of the PIVs?
I think as long as you explain openly to the people paying the energy bill what the heater is going to cost to run, then I don't have any issues offering it. It used to be the industry norm that the heater would give you a delivered air temperature of no less than 10 degrees, which, as we all know, is not warm. But actually, as the products have developed, there are systems that are much more intelligent and will give you more heat than that. So yeah, I think as long as you spend your time explaining to somebody, I personally wouldn't just apply it to a property without having that conversation, because there is a cost to pay to run a heater.
Yeah. And what we find when actually installing the PIVs, and we talk about the heater element and the ventilation, the running costs are not massively high, but they are higher than normal, aren't they? But it's whether they feel the risk is not a risk, but whether they feel it will be a benefit. But obviously you require that amount of heat within the roof space, because the temperature within the roof space is slightly more, isn't it? And it's using that heat to distribute throughout the property as well. Is that right?
Yeah, that's correct. I mean, I suppose all ventilation is bad from a heat loss point of view. You know, whether you're taking air out and letting outside air bleed in at outside air temperature, or whether you're delivering an air change, ultimately, you know, that's what the heating system in the home is there to do. So the study that I talked about earlier on, the BRE data logged, you know, temperatures in lofts, and what they were able to show is the loft is on average 3 degrees warmer than outside during the winter months. Why is that? Well, there's a bit of solar gain, and also warm air will rise, and ultimately, you know, you'll get a temperature uplift, you know, in the loft space. So the BRE were asked to comment on, you know, whether that was an energy benefit. And they concluded that compared with extract fans, it was. So again, let's think about extract fans. We take air out of the building, air comes in from outside at outside air temperature. Well, a PIV will deliver air in that's typically 3 degrees warmer, and that's 3 degrees less for us to have to warm up to achieve whatever comfort level we want. And what they said in the report, and I'm paraphrasing a bit here, is that it could represent a 10% space, a 10% saving on space heating costs. But it was certainly no less than 5%. So I think there's a clear energy benefit to PIV over and above extract fans.
Yeah, because obviously, you know, warm air rises, and am I right in thinking, obviously, you know, at the ceiling level, there's a lot of unused actually heat there from within the property, and what the PIV actually helps to do is redistribute that air. So in effect, it's actually taking some of that warm air which is wasted and actually reintroducing it throughout the property, which obviously presumably has benefits as well.
Yeah, you have stratification in homes, so there'll definitely be a difference in temperature between ground floor level and first floor ceiling level, and there's some evidence to suggest that the PIV will help destratify that.
Yeah, with regards, we talked about mechanical extract and obviously PIVs. You get a situation, for argument's sake, where you can't actually, for some reason, you can't get maybe a fan in a kitchen or a bathroom, and there's no ventilation there. There's products called heat recovery systems. Yes. How do they work differently from a normal extract fan, and what are the benefits of them?
Well, they're single room heat recovery systems that will take air out and absorb some of the energy that would have gone out to atmosphere, and then they'll push air in, and that energy will be passed on to the incoming air. And that's been a common method of ventilation for quite a long time. Traditionally, they would go into kitchens and bathrooms. There's a relatively new technology called alternative flow with heat retention that is typically applied to habitable rooms, so bedrooms.
Yeah, we've installed some in those instances, and they proved to be quite successful. But you can't put them in wet rooms. That's right, isn't it?
That's correct. Yeah. So you wouldn't want to be so to take a step backwards. They'll take air out for 70 seconds, stop, and then deliver air for 70 seconds. And inside there's a heat retention core, like a honeycomb, a layperson may call it, that absorbs energy, which is passed on to the incoming air. Well, in a wet room, you wouldn't want to deliver, you wouldn't want to push air into a kitchen or bathroom, because the danger would be that you might encourage that into the rest of the property. So they're designed for habitable rooms only, and I would say that they're relatively common within the preservation industry. Previously, we used passive ventilators to encourage ventilation into single rooms or areas where there's a lack of ventilation. And I suppose I look at this technology as just a very energy efficient way of doing that.
With regards, obviously, ventilation, what we try and sort of explain to our customers is ventilation shouldn't be just relied upon completely as a single fix. We talked briefly before, and I've talked about it in a previous podcast, about obviously, you know, the occupants producing moisture, what they can do to reduce moisture. We always try and say, what I'm always scared of sometimes is if we put a fan in, the occupants will they'll not forget their responsibility, but they might think, I don't need to do that because I've got a fan in. But that's simply not the case. And fans working alongside with what the occupants are doing, with obviously if they're reducing moisture, like I mentioned in a previous podcast, and the things you can do to reduce that, these things all together will help reduce not only moisture and condensation within properties, reduce the presence of the risk of mould developing, but more importantly, gives you that better quality of air, doesn't it, within the building?
I think there's a shared responsibility, and all the advice you gave in your previous podcast was as good as it gets, in my opinion. Think about your moisture generation. It is more common now for people to dry clothes inside. Interestingly enough, in Scotland we have building standards rather than building regulations, and those building standards require a drying space to be provided in a building that is served by an extract fan. Now, there's nothing to say it can't be a bathroom as well. So I found that really interesting, that the advice you gave kind of followed those standards, and it's advice that I commonly give, because I could be in a tower block, I could be 10, 11 stories high. It's unreasonable to expect somebody to be going down to the communal area and drying their clothes. But actually, I find that landlords are much more open to working with residents now. So providing tumble dryer kits where there's some space, or sometimes thinking about a washer dryer instead of if space is limited. But I think carefully about your moisture generation. Follow the advice that you gave in your previous podcast. Get a good, correctly sized, regulatory compliant ventilation system, and we should be well on our way to controlling condensation and mould in buildings.
Brilliant. No, that's great, and I concur with everything you've said. And it's great to actually sit here, because you speak to customers, to clients, and you when you're talking to them, it's nice to know that the things you're actually saying to them is been confirmed by someone with as much knowledge as yourself. Really appreciate you coming in and doing this podcast with us, Paul. It's been very informative, and I'm sure all the viewers are actually really take something from it. Thank you.
It's my pleasure. I get to visit a lot of companies within the preservation industry. I'm super impressed by what you got here. The Northwest is well served by you.
Thank you.
And the business you got, so well done.
Thank you, and great to see you. Thanks again.
All right, my pleasure.
Just to remind everyone, obviously you can subscribe to our video podcast. You can actually go on YouTube, type in RTC Preservation, and obviously press subscribe. Alternatively, you can go to the website and go on to any of our social media channels and follow us, because all this valuable information will be shared on all these. But also you can go on the website, go on to the podcast, and actually subscribe from there. So we'll very much look forward to seeing you for the next round of our podcasts, where we'll be talking about more property care matters. Thank you for joining us.